Welcome to Study Loop.
This is the answer to Chapter 13, problem number 1 from the Smith Organic Chemistry textbook. And in this problem, we're given 4 molecules, and we are asked to determine what is the mass of the molecular ion formed by the compounds having each molecular formula, and then they give us 4 molecular formulas. And so we should remember that the molecular ion, or the M to Z, is going to be equal to the molecular weight. So I'm going to abbreviate molecular weight as MW, and then the molecular ion is going to be equal to the molecular weight. So I'm going to abbreviate molecular ion as M to Z, because that's how it's given. It's a mass to charge ratio. And so across the top here, I've written the weights of each of the 4 atoms, each of the 4 types of atoms that are present in these 4 molecules. And so basically all that we need to do is multiply the number of each atom in a formula by its weight, and that's going to and then add all of that together, and that's going to tell us the molecular weight, and the molecular ion will be the same as the molecular weight. So for A, we have 3 carbons at 12 apiece, 6 hydrogens at 1 apiece, and 1 oxygen with a value of 16. And so when we add all of that together, we get 58. And so the molecular ion is also going to be at 58. And so that's how we're going to solve all of these. It's basically just multiplication and then addition. So 10 carbons at 12 apiece is going to be 120. 20 hydrogens at 1 apiece is going to be 20. So 120 plus 20 is going to equal 140. And so our M to Z is also going to be 140. So then we do the same thing for C. 8 times 12 is 96. 8 times 1 is 8. 16 times 2 is 32. And when we add all of that together, we get 136. And so the M to Z is also going to be 136. And so D, methamphetamine, has a nitrogen in it. And so nitrogens, the presence of a nitrogen is often indicated by an odd-numbered molecular weight and an odd-numbered M to Z. And you can see why. So whereas in the first 3 we had even numbers of hydrogens, in D the presence of a nitrogen forces there to be an odd number of hydrogens, and so that's where our odd number comes from. So for D we have 12 times 10 is 120, 15 times 1 is 15, so 135 altogether, and then nitrogen has a weight of 14 for a total of 149. And so again, that's also going to be our molecular ion. And so that's the way to approach this problem. We just need to know what each of these atoms weighs. And then the formulas tell us how to do the math. And then the molecular ion is equal to the molecular weight. And that's the answer to Chapter 13, problem number 1.